Cool. So thanks everyone for joining this webinar today. We lined up a few great people other than myself. My name is Gad. I'm the founder of TensorOps. I'll be presenting our company soon. We have today Gabriel Gonçalves, who is a solution architect at ours, Miguel Neves as well, solution architect, and Guy Eshet. He's from Quack. Guy, you want to maybe say a few words about Quack and what you do?
Hey, welcome everybody, and thanks God and the TensorOps teams for giving us the opportunity to join. Just one word, I think, on Quack. What we do at Quack is basically help companies deploy machine learning at scale. We simplify machine learning flows for companies as big as Notion, OpenWeb, and NetApp, and as small as startups just starting up. And we do everything end-to-end from model training, deployment, automations, data engineering. So it's kind of a one-stop shop for companies to deploy their models and to scale it up. And like traditional machine learning, and especially these days, LLMs, like this topic. Got it?
So about TensorOps, so we are a consulting company, basically our partners in AI. What we do is we help companies build a solution based on their business needs. We are cloud agnostic, so we meet the customers on where they are in terms of their technology adoption and help them out deliver these amazing products using AI. So that's enough about the introductions. And today we have an interesting topic. We're going to talk about the breaking down the cost of LLM applications. And we know that cost has been an interesting topic, especially for companies these days as they are moving from the POC phases into more serious deployments. And we decided to share some of our insights from working with a few of our customers and partners on these cases. So one thing that would guide us through this webinar is that if you came here to think that there is a magic trick that would probably solve all your problems and you'll be able to just decrease all of your cost by just tuning into this webinar, I'm guessing that that was not realistic. So you'll often find that we will be speaking about how you can balance a few dimensions of this problem, whether it's privacy, whether you want to choose a service that is very high efficiency and gives great result, but you're concerned about sharing the data with them. And of course, go to market. Like if you had the infinite amount of resources and time, you might have been able to actually come up with your own solution, but that's not always realistic. So maybe just before we kick in the first topic, I would suggest putting up the poll. And it's interesting to see where are you in terms of spend. So mostly focusing on if you're building an application, where do you see yourself? So if you want to kick off the poll. You done? Did live? Okay. So I'll give you a few more minutes. We're basically asking people at what kind of category you are in terms of controlling your costs. And I'm seeing responses coming in. We're gonna give people a few more minutes to give this answer. Nice. Yep, I think you can share the results. So it turns out that most of you are at the lower bracket of this distribution. And that maybe correlates to what we see with customers. Again, they are in the POC phase. So we see them not yet spending the whole amount, but there are at least a few answers here from people that are spending above $10,000 per month on LLMs, which can indicate that what they're doing is a substantial use. So it's an interesting insight already. And the agenda for today is actually going to focus on four topics. So first of all, we're going to do a breakdown. We're going to ask, what is the cost of LLM applications made of, right? Which is the most interesting, the most basic stuff that you need to ask yourself. What are you actually paying for? And then we're going to focus on a very, very important topic is what's the right size for your model? We're going to introduce a subtopic of that, which is LLM quantization. So I don't know if you know about LLM quantization. That could be a webinar of itself, but LLM quantization is kind of a magic trick in order to get the bigger models that are hyper-performing a little bit smaller or significantly smaller, but still maintaining an adequate level of accuracy. And then we're actually going to introduce a quantitative analysis approach. So we're going to say, in order to really optimize your LLM application, you need visibility and you need the ability to ask yourself quantitative questions in the regards of accuracy and latency and performance and whatever you want to do. And we're just not going to talk about it. We're actually going to show you a demo how we build this on top of Google Cloud. So Google Cloud is just an example. If you're running on AWS or you're running your Quark, you'll be able to build the same kind of monitoring dashboards for yourself using open source tools. So it's really worthy to stick until the end of the webinar for this amazing video. Demo, sorry. So without further ado, Gabriel is going to talk to you about the use case that's going to guide us through this webinar.
Right, thank you. So I just wanted to start off by kind of presenting the use case that we're going to be using throughout the webinar. So just a simple airline customer service chatbot for an airline, let's call it TensorAir. So essentially, this chatbot would serve to respond to questions like, which baggage can I bring to my trip? Can I bring my pets on board? Simple questions like this that don't require much thought for a human, but for chatbots can be quite challenging, as this would require consulting complex documentation, internal documentation for the airline. So this airline would also be expecting a low rate of requests, but high variance, so somewhere between 0 and 100 per hour. So we wouldn't expect people to be asking questions to this chatbot at 4 a.m., but the volume can get up to 100, which is still quite high in terms of the scale of LLMs. And we would be expecting to have, we would be needing to have low latency, so we wouldn't want to take more than 10 seconds to respond to the users, as it would feel quite unresponsive. And there's not really much privacy of data requirements in this case, because we're not really using payment informations or identifications. The most private information that we'd be handling would be reservation numbers. And of course, we would need it to be accurate so that we wouldn't give wrong advice to our users. So essentially, the way I would start to tackle this project would be to start kind of pasting some of this documentation on ChatGPT's prompts, and then just trying to test out some test questions to ChatGPT. And I would probably get really good results out of the box and be really happy about myself. And this is kind of how the discovery of LLM projects tend to end. Everything looks really good. But then you start iterating on the initial discovery, and you need to do some prompt engineering, you need to do more LLM calls for validation, guardrails, and then everything starts to become slow. You need to pay for embedding, so everything starts to get expensive, and then more tokens, everything you just can't quite get to the last part where you go to production. And why can't you get to production? Because of the economy of these systems. So so essentially the mistake that was done here was that we didn't quite take this into account at the beginning. So we need to understand that the economy is important from the get-go, so that we don't have to kind of go back on our decisions and go look for a cheaper model because we realized at the end that it wasn't economically viable. So essentially, architecture decisions must take this unit economics into account from the get-go.
Yeah, I think I would say at this point that what we see is that like LLMs are an amazing tool, right? They're like the SpaceX rockets that can go into space and go back, which is an incredible piece of technology. But it doesn't mean that you're going to take this this rocket back and forth to your grocery store just because you can. So, and the reason why you don't do that is because of the unit economics. And I think if I'm looking at the difference between 2015 and 2023 on the attention or the technical debt or the debt of machine learning systems, so there is a major shift, and the major shift is in the cost. What do I mean by that? Imagine that you had a language model back in 2015, it was probably based on some bag of words, and you would have to invest a lot on processing and cleaning the data and structuring the data so you can work with it and put it into your random forest. And the costs of random forests were not that expensive, but you had a lot of technical debt around it. What happens these days is that LLMs are substantially more sophisticated general models, right? You can just put in your inputs to them and get the responses that you want, but it doesn't mean that it comes with at no cost. The cost is actually being transformed into the payment that you're going to, the cost that you're going to pay for maybe cloud costs or OpenAI costs or LLM vendor costs. And this is, I think, a major notion that we're seeing. The loss of the complexity of these systems kind of transitioned itself from you being developing all of this to you're just going to pay for it. And this is why the LLM costs are, in one way to look at why the LLM costs are more important for AI application that has them.
So I kind of told you about the context that you need to answer these questions. So this kind of leads us on to this being a RAG system. And if you're not familiar with this terminology, it means retrieval augmented generation. And essentially, we've done a webinar about it before. I recommend you do go and watch it, but not right now. Essentially, my point is that there's a lot of peripheral parts in terms of feeding context into these models. And all of these parts have costs and a lot of complexity added. But in this webinar, we're mostly looking at the LLM APIs and hosting part, where I would say about 80 to 90% of your costs are going to be actually in this part. So to talk to you a bit more about this LLM pricing, I'm going to pass the word to a Guy from Quack.
Thanks, Gabriel. And I think that it's best to start with the fact that you need to get LLM for chatbot. Now, you want to do a cool demo and you want to start. So you'd have to get your LLM. What are your options? So first, most people go to OpenAI, which is really one of the easiest options. But we actually have two options. Either go to LLMs APIs, for example, OpenAI, Anthropic, Cohere, or many other providers who give us LLMs API. Or we could deploy our own model, which usually are one of the open source models. Lately, Llama 2 has been the most hyped. I think there are more coming, Mistral and others, but they mostly would be open source models that you would have to deploy on your own. Sir? Yeah. Now let's start before that. How do you measure LLM cost? How do you kind of quantize this? And everything is about tokens. Now, tokens are the basic unit in LLMs or in models. Basically, one token is about 4 characters, and in one word, an average word is about 6 characters. You would have 1.5 tokens. Now, bear in mind that every model has a different token count. As you can see here to the right, this is from the OpenAI website. This sentence, LLM usage is measured in tokens, has 8 tokens, which are, this is their breakdown, but the breakdown varies, as we'll see soon. Why do I say all this? Because always when you go to these API pricing pages, you would see the price per 1,000 tokens. Also, bear in mind that you pay for the tokens into the models and out of the models. If you give the model a prompt and you get a response back, you're measured mostly on the input and the output. If we take from the website, for example, GPT-4 costs 6 cents for 1,000 tokens, which is about 240 words. And almost every API provider that gives LLM would price its tokens by 1,000 or by millions. So it's important to know. Now, not all tokens are equal. Gabriel, for example, did a very interesting research, and he compared the same model with different languages. And we discovered that different providers, Anthropic, OpenAI, Llama, Mistral, they have different token counts for different languages. So for example, you can see here in Thai, for example, Mistral has a very high token count for the stuff in Thai, and different languages behave differently. Why do we say all this? Let's say your airline chatbot serves only people from one certain language. There might be a chance that some models would be cheaper at scale than others. So, but slowly we get more and more concerned that we never had before. So this is more and more we have to think about. And why would you go for this model? Why would you go for an LLM as API or pay by token? First, it's amazing and it's really the best for in 2 seconds. You can start tinkering with your project. You can have a demo. You're still using the highest quality models. These API models are still one of the best in the world. And there are no fixed costs. You pay by tokens. So you used it one day, you pay, you didn't use it, you're not using it anymore. Where does it get complicated? First, depending on your privacy concerns. I'm not sure how stiff your organization is, what is the compliance that you have to stand with. So this is one thing. Second is latency. Lately, we've been getting a lot of requests, a lot of complaints from people saying that GPT is taking between seconds and minutes to respond. And if you have live use cases, you can't have this latency in production. And three, and I think this is kind of one of the reasons for this webinar, is what happens when you scale. Now, scaling can come from 1 user to 2 and can come from 2 users to 2,000 and more. What happens and how does the price look when you grow up? Now, one very important thing to note, as I said before, you pay for input tokens and output tokens. And more than that, you need to remember, as we saw before, you're working, it's like a networking protocol. You have your question, and then you wrap it up in a prompt, and then you wrap it up in a chain, and then you use more and more stuff. So eventually the price that you pay is not just the questions that users send from the chatbot, is the entire kind of influx of words to the model and from the model. And at scale, these can be quite pricey. Now, alternatively, what we can do is we can host our own model. Why would we do that? I just want to go to this slide before and show this, for example. It seems cheap. GPT-4 is just 6 cents for 1,000 tokens. However, if you take this with 5 requests per minute and 350 words each in and out, which is quite reasonable when you talk to LLMs, you're going to get an almost $10,000 a month. Now, maybe this is worth your organization. Maybe this is even cheap for you, but you need to take this into consideration, because if you took a cool demo and scaled it to all your user base, you could get into tens of thousands and even more dollars a month. And as we saw in the poll before, we had participants in this poll paying these prices. So this is actually viable. And we know of people paying in the hundreds of thousands every month, which might be okay and might be even profitable for the organization, but you have to take this into consideration. I want to go to this slide before and then bring the question, why would you host your own model? So first, at scale, sometimes you do get lower costs. For many types of models, you could get better instances and you don't pay this premium that you would pay for an API provider. Second, you get control of the latency and infrastructure. You are in charge of the servers. You can scale it in and out. So you know what you're getting and you get this, and you know this with visibility as it happens. Three, the open source models, as we've been lately seeing, are getting better and better every day. Gabriel and Miguel are going to discuss later how do you benchmark and how do you compare new models. But as we see, every day we get a new, better one that kind of competes with GPT and this and that. And four, which is also very important in the unit economics of models, for some tasks, you could choose a smaller model. Not all models need the best, not all tasks need the best models. If you just want to choose an emoji for a sentence, if you just want to detect a language, you don't need the best LLMs. And sometimes you could use a small open source models at scale that would serve your kind of task, and this would be cheaper. Now, what are the cons of hosting your own models? First, you have fixed base cost. You spin up servers, you spin up models, and there is a base cost. If you're not using the service, you will pay on a fixed basis. Second, some proprietary models are still better at very complex tasks, and you wouldn't get this with open source models. And then three, it does require management, it does require model selection, it does require kind of more effort and engineering from your side. Now, wait a sec. Yep. Now, it sounds sometimes it's just, hosting your model is just downloading something from Hugging Face and that's it. Like, let's take an instance, let's put a Hugging Face model on this, and it's going to be enough. However, we're talking production scale, right? Now, production scale can be for 2 million users and it could be for 1,000 users, but you want to have zero downtime. So this is what I say when I talk production. It's not just having infinite scale like ChatGPT, it's also having zero downtime, because every minute your product is down, users are getting angry. Now, at Quack, what we do is we help companies deploy models at scale. We have companies with millions of users and thousands of users. Now, when you do want to host LLM in production scale, you need to choose your GPU instance. You need to create redundant deployment for zero downtime. You want to kind of toggle between spot and on-demand instances to save cost. You want to support auto-scaling. You don't want to do A/B testing because you want to switch to a new model and see how it feels like. As we saw before, you want to add logging to it. You want to do automations. And lastly, many users that we have are using batch inferences. Batch inferences is actually taking a huge chunk of data, whether from a database or a file, and just running inference over it. So not everything is a chatbot. Sometimes you want to do different operations. These things take a lot of time and engineering. Now, you could start with this, but it's more than just spinning up a Hugging Face model. And this is what we do, and we see the challenges that companies are facing. For example, one of our customers decided to deploy their own embedding models and not use OpenAI because of their scale, and they save about 10x the cost if they used OpenAI embedding model. Now, again, it's not for everybody, but at some scale and at some usage behaviors, it would be more wise to take your kind of models in-house or onto a platform like Quack and deploy your own stuff. Now, if we go back kind of to the chatbot use case, in the phase of going from a demo to a live POC, one of the things you'd have to do is really to see what happens when you move beyond prototyping. And for that, I'll give the stage back to Gabriel.
Yeah, so essentially I told you about the growing complexity of these systems, but I didn't really give you an example. So here we are. So essentially, let's say that a user wants to interact with this agent to answer his questions about travel, but what exactly does this agent interact with then? So how does it get the information? So I told you it would be a RAG architecture, so you need to interact with the retrieval system. But now let's say we need to retrieve the flights for today. That's a very structured type of knowledge that needs to be saved in something like an SQL database. But then at the same time, it needs to have some guidelines for baggages and pets and stuff like this. And this is a more unstructured type of document that could be in a vector database. So essentially, we right away, just as we start to develop it, we're already doing stuff like having two models, one model for answering the questions of the user and another to just translate the queries of the user into SQL queries to get simple results. So this brings me on to which decisions we're already identifying in this system. So I told you we would have two models here. So, okay, we need to pick which models to use. We don't necessarily need to have to pick the same model for both. So for the main agent, we would probably want to pick a bigger model since it's interacting directly with the user. It needs to make decisions how to interact with this retrieval system. We could pick a bigger model like GPT-4, for example. But for the text to SQL model, this used to be kind of a bleeding edge application, but right now even smaller 7 billion parameter models can do it. That can even run on your laptop. So you could pick a small model and fine tune it to your schema. And then there's smaller choices like embedding models, vector databases, which you have pretty much thousands of options these days, which have a lesser impact in your cost, but they're still quite heavy in the long run. So now I'm going to bring it over to Miguel to talk to you about how exactly do you pick the right scale of model for your specific use case.
Yes, thank you, Gabriel. So as you've all seen, picking the right model is really one of the central things. And models really vary by size. So I think it's important to first understand what actually makes these models so big. And the main factor is actually the amount of parameters. So state-of-the-art models go anywhere from 7 billion to 1 trillion parameters with the likes of GPT-4. These models need a lot more training data, trillions of training tokens. In addition, each parameter has high precision, which means it occupies more memory. If we actually do the math, a 1 trillion parameter model would take about, in high precision, would take about 2 terabytes of memory, which is really a lot. It's such a high value, right? Now, I'd like us to take a step back and look at how we got here. How did models actually get so big? So if we look at this graph, we can see from 2017 that models have been increasing exponentially in size. In fact, they've been increasing by a factor of 10x each year which is, I mean, just amazing, right? But the costs also increase with that. And if you notice it, up until 2021, the size have been increased, but now from 21 until now, the sizes have been kind of flatlining. Now, this could be due to hardware or some engineering tricks still being missing, but one thing is for sure, models will keep growing, and we can also expect smaller and open source models to keep growing and start closing the gap to state of the art. But why is there this race for bigger models, right? What's the interest behind this? And the thing is, researchers have come to the conclusion that bigger models are generally better. They do more things and better. So let's take an example of you're training a big model to do a specific task. You want it to summarize perfectly. You start training it and it gets really good at summarization. However, it also starts learning how to do different skills, like translation, arithmetics, and others. So it can generalize quite well outside its training data. Now, this would not be the case with a smaller model. Smaller models can be very good, but at specific tasks. So a smaller model could even outperform a big model on a very specific task, but it would have some difficulties doing other things. So if big models are so good, why don't we just use them all the time, right? Well, there are some downsides. Using a big model usually means that you will have to use LLM provider, such as OpenAI, because you might not be able to host them on the cloud. This means you get dependent on OpenAI or your provider of choice. This does have some consequences. You will be subject to their decisions. So let's say they decide to suddenly change the pricing or even the privacy things, right? And you have no room for negotiation. They'll just change it and then you're exposed to it. It's also really easy to get vendor locked. So you can get locked into using OpenAI and it's hard to get away from it because the code from one provider to the other is different. And you can also get model locked. What does this mean? Let's say you're using GPT-4 and you now want to move to Anthropic. So you want to use Cloud. How GPT-4 responds to a certain input will be slightly different than Claude's. And therefore, your system might not work, which means that trying to move from one to the other will not be as straightforward as you want it to be. And you might have to do a lot of changes. So it's not so easy. In addition, you can, by using these types of provider, you have no control over specifics like latency and cost. You're working with a black box. So you get chained to these providers. It's hard to move out of them. So now let's see. And you can ask Sam Altman about this. When you are inside OpenAI, it's hard to get out. And if you do try to get out, you might find yourself coming back in because, well, it just works, right? You just have to pay for it. And that is true. And with that, I'd like us to go back to one of the first slides we covered. So Guy talked about this slide a little bit. It's about the three main pillars of economics and how to choose your model, with them being the privacy, the accuracy, and performance, right? And this is all constrained by the time to market. But I would like to add a new axis, a new dimension, which is flexibility. When you're choosing a model, when you're choosing a solution, you don't want it to be static. You want it to be adaptable. The requirements will change with time. Providers will change with time. You want to be able to adapt quickly. So you also need to think of this axis, and it might make more sense for some applications than others. It's up to you to decide. But I'd like us to now look at a practical example. Let's take a look again at the airline chatbot. We have some requirements. So we need low cost, low latency, high quality of answers, but there's no need for privacy. For sake of argument, let's say we already have a POC. We worked with OpenAI, we built a quick demo, it's working. We need something better now, but we do have some months for development. Now, one possible solution, and I do want to highlight this as being possible solutions because there are more than one, would be, in fact, to host your own model. So this airline could host its own model, could have higher control over costs and latency and the requirements, and be less dependent on others. And I would argue, most importantly, they would gain in-house knowledge for the future. Let's think about this for a second, and I do want to focus on this particular topic. The AI field is changing dramatically and at such a rapid pace. We see things appearing and companies appearing and going away really fast. So it's hard to navigate these tides. You don't want to get tied to anyone. You don't want to get exposed to so many risks. You want a more robust solution. So ideally, if you can control everything yourself, if you can expose yourself less to these variations, it could be an investment into the future, right? It depends on the use case. It's just a personal opinion that it might be interesting. Now, I do want to take a tangent here, and let's see. We talked a lot about large models, but how can you actually match these large models using smaller models? There are several techniques you could use. There's prompt engineering, which we actually discussed in a previous webinar, fine-tuning of a smaller model, or some newer techniques such as model distillation and model merging. Now, we do want to focus on model LLM quantization. LLM quantization is pretty much the action of compressing a large model into a smaller one. So we'll just take a quick dive into it. So how does LLM quantization help? How does this compression help? It's important to remind ourselves that LLMs are no more than matrices of numbers with decimal points. And if we can use less digits to represent each number, we increase efficiency, we lower costs, we lower latency. So this is the idea, right? Now, let me give you a framework to think about this. Let's do a parallelism with image compression, say JPEG compression. Quantization is similar to this. If you pick up a really high quality image, 4K image, and you compress it to half the size, the quality is still going to be very good. But now let's say you pick up a bad image and you compress it. It's going to be terrible, right? It's exactly the same with LLMs. Big models, when compressed, tend to maintain most, if not all of its quality. So the question then is, just how much memory can we save by doing this? And now I'd like to call your attention to this table. We have the original sizes of these lemmas and the quantized size. So in particular, let's look at the original size of the 7 billion compared to the 13 billion quantized. And in fact, we can see that the 13 billion quantized is almost half the size of the first one, right? Such a difference. But what about performance? Let's see. So the bigger model is in fact better because, like we had talked before, models with more parameters are generally better than smaller models, when in fact the memory it occupies is smaller. So this is awesome, right? It's a great technique, and we can leverage it to do very interesting things. I'll show you one of them. You can use it to run your LLM on your personal MacBook. Yes, this is incredible, right? Personally, I thought this would be like years away, where you could run 7 billion models on your own machine.
When people are saying that they're running, so I'm seeing this, and this is maybe something that I'm always getting. On one side, you're hearing, in order to host my LLM, I need this machine on the cloud that costs at least $10,000 per month. I'm maybe just throwing numbers in here. And then on the other side, you're seeing all these YouTubers saying, I'm running the LLM actually on my MacBook, and it's like the biggest llama, I'm just running on my MacBook. So is this what you're talking about? What's the difference between those who are saying I need the biggest machine on Amazon to run LLMs, and it costs $50,000 per month, versus those who are saying I can run it on my MacBook? Yeah, so exactly. It's for different use cases, right? So on one hand, you can need like a really large model, but for many tasks, a simple model will suffice. And if you can run it locally, I mean, you're not paying by token. You're just using your local machine to do simple things like recommendation or even spelling, detecting spelling errors, things like that. And with these libraries, I mean, you can just do it in 1 or 2 commands, which is simply awesome. Yeah, and I hope I get you excited about these techniques. There are a lot more that we will not cover, but that you can research. And with that said, I'll pass it over to Gabriel to discuss some of the problems with LLM benchmarks.
So we've talked a lot about how to make models smaller, how to host these models, but we've never really talked about what's our entry point into getting these models in the first place. So what a lot of people use for this is essentially to use reputable benchmarks or LLM benchmarks in general. So my advice here is to basically just get 1 or 5 of these benchmarks, adjust your expectations to your budget. So don't look for 70 billion parameter models if you can only pay for 7 billion ones. But don't just pick the best one in the table. Try to pick more than one, and I'm going to kind of explain to you why in a bit. And also be mindful of the licenses of these models and try to find benchmarks that fit your use case instead of just the most generic ones that tend to be a bit more popular. So now I'm going to tell you exactly why I'm kind of not a fan of these generic benchmarks. So Alpaca-Eval is one of these benchmarks where you kind of use GPT-4 as a judge to what the best output for a model is. And in this case, when you look at it, you see, so in blue, you have the open source models, and it sure does look like OpenAI is getting overtaken soon by the open source community, where we see Llama 70 billion parameters outperforming GPT-4, which looks pretty weird, right? But then once you go to Chatbot Arena, which is a human preference benchmark, we see that the top 6 are all proprietary models. So what gives here? So why is there such a big gap between the headlines we see on LinkedIn posts every day and what actually happens when humans choose what the best output is? So essentially, there's a survivorship bias here where we hear about these models that outperform GPT synthetically more often. There's also kind of a gamification of these leaderboards. I like to call them scoreboards at this point. So these research groups have a very large personal and financial incentive to score high up on these leaderboards because they get good exposure and they can even get funding from this. Also, there's the aspect of LLMs not being good judges for other LLMs. So for example, in the Alpaca-Eval example that I showed you, GPT-4 is known to be biased towards other models that were fine-tuned on GPT-4 outputs. And this is something that I think goes against OpenAI's terms of service to actually do this, but people still do it, and then they end up high up on these leaderboards. So that's kind of an interesting one. And there's a bit of a hype cycle around open source in general. So this is the same thing as happens with open source operating systems. So every year, next year, Linux is going to be the biggest OS, and then it never happens. And 20 years later, here we are. So what should we take away from these gaps in performance? So essentially, don't make your decisions and important decisions based on a single LLM scoreboard alone. And you should establish your own evaluation pipelines. You should kind of see for yourself. And you might think this just takes a lot of work, but think about how dynamic LLMs are as a field and how useful these evaluation pipelines can be when Llama 3 comes out and you're just 3 months ahead of your competition in implementing evaluation and fine-tuning pipelines for your own organization or company. So now I'll bring the word to Gad to talk about an analytic approach to LLM cost.
So eventually, I think what we try to establish is there are some considerations, right? So there is the size consideration and the latency consideration. And Miguel even tried to show a hack in which you can get a really smart model, shrink the precision, and not lose too much on the accuracy, and still get shrink a little bit the precision, and not lose too much on the accuracy. And then Gabriel is coming saying, the benchmarks that you're going to find online about these models are always going to be really biased, right? Anthropic is coming with a new model. Of course, in their benchmark, it's going to be better than ChatGPT. And there is this open source model that makes a comparison to ChatGPT, and they said they're beating it, but they were fine-tuned on ChatGPT. So how do you actually come up with your own decision? So we're going to try to show you that with LLM Studio, which is our open source. Going back to that company, so there was this company that was building this chatbot that we discussed before, and they went online with their chatbot, and they're seeing the first bill, and they're getting a bill shock. And they're saying, okay, so OpenAI is maybe expensive for us. Anthropic are saying that they're cheaper. and there is also the Google offering. So how do we balance all of these promises? Because you can just imagine that if I just unplug ChatGPT and put OpenAI and put Anthropic back, I might get something completely different in the results. So, and I don't know even how to measure if that was worthy for me in terms of cost. So the idea that we think as a company we should solve it for our customers as we do consulting project and cost reduction project, just a sec. Yep, sorry. So the way that we think about this is that we need to sit essentially as kind of a proxy between the service or the user and the LLM. And we do it with an open source software that we call LLM Studio. So the idea is that it serves as a gateway that centralizes all the access to LLM applications, whether it's Anthropic, AWS Bedrock, Google, OpenAI, whatever LLM. Even if you self-host your LLM, you can still create with this open source a connector to your local LLM. And then on top of that, it provides you a lot of currently missing features like SSO and audit. But essentially, once you are the endpoint through which all the LLM calls are being called, then you can introduce logging. And once you have logging, you can get analytical about your LLM application performance. And this is the concept of LLM Studio. Again, it's an open source, so you're not sending anything out of your existing ecosystem. It's not a service that you're risking by sending your credentials to a third party. This is all hosted within your application. So moving forward, the company wants to achieve something like that, right? Essentially, if you want to get cost reduction, you want to ask yourself whether simple questions like, how much am I paying for OpenAI? Because once you have this endpoint in between, or like the API gateway, we can say, or the LLM gateway, you can ask yourself, how much am I paying for ChatGPT? How much am I paying for Claude? How much am I paying per user, right? If you want to understand your unit economics, you may want to tag user sessions and go back and collect that and do this average of how much am I paying per user session. And through this analytical approach, which basically logs all these operations, you can then go back and do this optimization and say, so actually this part of my system is a retrieval system, and a retrieval system needs a metric of click-through rate or feedback from the user, up and down, or good, bad. And that is really powerful when you do that with LLM Studio, because you can just build your own metrics on top. So it's not. I've seen a few solutions that are trying to tell you what's the right metric for you, but essentially it's a rabbit hole. You're always going to try to find a metric that is. You as a business, you always try to find a metric that is most suitable for your business needs. The idea that if you want to look at it architecturally is on the top, on the bottom level, you have the LLM vendors, right? Whether it's going to be OpenAI or Anthropic or Google Palm or Llama or Hugging Face. And then on top of that, LLM Studio sits as an API gateway. And on top of that, you have your own data warehouse or logging system. So whether you're using cloud monitoring, you can just send it. Whether you're using Snowflake, you can just save the logs into your data warehouse. And once the data is in your warehouse, you can easily build these dashboards, achieving the required cost reduction. So what is LLM Studio? How you going to work with it? Essentially, it's a Python package. It's again open source, so you can just pip install. It also has a UI. I gotta say the UI is not the bulk part, but it's really easy to demonstrate. And Miguel is going to show you a little bit of demo using the UI of LLM Studio. So you basically just pip install LLM Studio and then you run the server. And Miguel is going to start now a demo about how we can build these dashboards on top of LLM Studio. I think you're going to love it.
Yeah. So if I can ask you with them to stop the share, perfect. Okay. Nice. So are you seeing my screen? Can you confirm it?
Yeah, we're seeing your screen.
Yeah,
you're seeing LLM Studio.
Nice. So this is LLM Studio's UI. Let me just go over what it is real quickly. So on the left, we can insert inputs, you get outputs, and importantly, you can choose your models. Now, do notice that you can choose models from different providers. So this abstracts the whole need for actually doing coding or researching into the architectures or the code of how to use each provider. You can just set up your API keys like I've done before and use a provider. You can change the parameters and you can just talk to it and maybe do some prompt engineering, so improve your results. Now, we did say that this demo would be about something in production. So let me show you how LLM Studio actually interacts with an app in production. Let's pick up our favorite example, right? Airline travel assistant. We have this bot here, which has been built using LangChain and using LLM Studio. So LLM Studio is wrapping LangChain and it's using it behind this app. And do remember that it is open source. So let's ask a question. How could you help me? And let's see the answer. And it answers us, okay, I can help you with many things. So let's actually ask it a more complex question. So I'm arriving late. I'm now at the airport. What should I do? Give it the answer step by step. Okay, so this is quite a stressful situation. We'd need the model to answer us. And the answer would need to be quite accurate. The model does answer us. And the interesting thing about this is because we are using LLM Studio behind this, actually all of this is being logged in real time. And we can use the UI in order to see this. So let's go back to the UI. If I refresh this, you can see that now the inputs and outputs, which I just did, appear here, along with all of the logging. So you can see the input tokens used, the cost, the latency, and whatnot, the parameters, etc. And if you actually want to deep dive into one of them, you can go here and just click Restore. Now, this gives us a big input, but this input also includes the system message and the instructions given to the model, so you can analyze if it's exactly what you wanted. And then we have here the question, which I just did, and the answer. Now, the interesting thing about LLM Studio is that imagine that the answer was not exactly what I wanted. So it was a mistake or something. I want to change it. I want to understand why the prompt was not perfect. I could just quickly go here and change anything. So I'm just going to do something funny and ask it to answer me like a pirate. I want it to answer like a pirate would. I'm still using GPT 3.5. I'm going to increase the temperature for more fun. And let's see the results. And now it actually gives us the step-by-steps, but like a pirate would. This is just a funny example, but you can see how it could be used in order to solve an issue. So imagine you're a user and you are talking to the chatbot, and this is a bad response. So I'll give feedback that this is bad. Then an engineer could actually go check out the feedback of the bad ones, come here, restore it, and see, why did it get a mistake? Change the prompt and iterate until it gets a good prompt, good enough to fulfill this. So yeah, with this, I think the value of LLM Studio is pretty clear. And with these logs, you can also export them. So if I just come here and I select export all, I can export this in a CSV. And it integrates into any logging or observability platform you would use, like BigQuery or whatnot. And you can actually use, for example, like we did, Looker Studio to generate these dashboards, which you've previously seen from actual data we got from using LLM Studio. We can compare the models. You can see the cost per hour. If you want to select a specific model, you can select it and see its cost. So yeah, I think it's really interesting, and the added value is pretty clear in how it could help you lower your costs. So yeah.
Yeah, and at this point, I would say that we are working on, so you saw that Miguel basically downloaded the history from the local storage. So LLM Studio currently, I think, implements a SQLite storage as part of the application, but we are working on a more clear framing of the data access there. So you'll be able to send it directly to maybe a PubSub or BigQuery or Snowflake or whatever logging system you have, and that would go into your data warehouse directly, so you don't have to manually download that. That's coming in in a very few weeks. So again, in the meanwhile, if you want to support us by giving a star, making a pull request, opening an issue, testing out the library, this would be very, very much appreciated. We are living off this feedback. So every feedback that you're giving us is motivate us to continue supporting this this initiative. That's it. Miguel, want to skip to the next one? I think that we've seen the approach that we kind of like try to convey, which is LLM application is not just going to OpenAI. It's complex, and it's a system that do multiple calls to multiple LLMs, and you need to figure out what's the right LLM for every call. And in order to decide that, you need to come up with the business metrics, whether it's latency, whether it's click-through rate, whether it's accuracy, and most of these can be measured on by your own means. And in order to do that, what you need to have is a proper logging and monitoring. And once you go to production, it's going to be critical, but you do need to think about it even before going to production, because even if you went to production without testing your system around these sharp edges, the migration is going to be much more painful. So I want to thank everybody who participated today. We've seen some questions in the chat. There has been some questions that we may have not answered. If you have more questions in the chat, feel free to drop them. We'll be sending you emails with the recording and with the links to references. And if there's questions we haven't answered, we're going to answer them in the follow-up email. So thank you so much. And we'll see you in the next webinar.